Hey everybody, this is Armin. So this video is actually starting most of the way through a project, and I want to explain the background of what's going on before we get into the actually assembly of the car part. So this is a whole project about doing a transmission and differential swap, as well as a high horsepower build for my NC Miata, also known as the Blueberry. It's the car that's sitting here behind me. So a lot of people have done turbos, higher horsepower stuff, but they start to break their transmissions or they break their differentials. So a lot of people have limited their power output because of this. So I came up with the bright idea to see if I could get a different transmission and a different differential, as well as just do some stupid horsepower stuff. So here we are. What I've done is I've gotten together all sorts of parts. I've come up with some products that I've had to make. I've had to come up with some of my own solutions to fix all of these problems. And I'll be going over a lot of that development stuff in this video. So as of right now, I have a plan for how this project is supposed to go all the way through to the end, but this is all one giant experiment, so we'll see how it ends. So let's get to explaining. So I'm going to start in by explaining the transmission choice and the obstacles that have gone into this. Thus far with this whole setup, I based everything around doing the transmission, because the transmission is really the weak point. And I know I'm going to get some fire off of this one, because I chose to use an MT82 transmission, which a lot of people do not like. But the truth of the matter is, at the price point of getting an MT82 versus getting a custom-made dog box or race transmission, it just made sense. So that in the MT82, specifically the EcoBoost model, it shares bell housing bolt pattern with the Duratec, because we get the EcoBoost motors out of the Ford Mustangs and out of the Ford Rangers, and those are the successor motors to the Duratec, and the Duratec is what I put in the Miatas. So I did a little bit of research, and then I went ahead and ordered up an MT82, and I figured out that they bolt up. Now we are missing a couple of bolts from the oil pan segment, because the oil pan off of the Miata is much more shallow, but I did have to overcome a couple of other obstacles. So if you guys are familiar with Miatas, they have a power plant frame. The power plant frame is the support of the back end of the transmission connecting to the diff. So the Mustangs don't have that. So what I had to do is come up with a V-mount or U-mount based on what it looks like. You know, it's more like a U, but I had to support the back end of it. So I pretty much mimicked the way that you guys do V8 swaps, and I just came up with that U-mount, and it plates in on the sides of the transmission tunnel. The Mustang motor sits upright while the Miata motor does sit crooked, so I did have to take into account that in the center console. The shifter is moved back maybe 2 or 3 inches and over to the right 1 or 2 inches, but at an angle as well. And that again is because the motor in the Miata is crooked, but the transmission is upright, so the transmission ends up sitting crooked. That's not the end of the world. I went ahead and took a second generation Mazda 3 emergency brake, because it is an upright design, and I have fabricated up a mount to put it to the left side of the center console that clears the shifter position. The shifter position I came up with by going with an MGW, since that is the preferred shifter for any of these muscle type cars. And the MGW company actually has multiple lengths. You can get stock length, which is about, if I remember, it's about 12.5 inches from the mount point to the center of the shifter, all the way down. There were like 3 options to get it down to 6 inches. So I got the shortest one possible. It's a very compact shifter, and that attaches directly onto the transmission. So we have a shifter that still fits in an okay position. And then I did come up with a center console, the aluminum center console that you see here. It accommodates the position of the e-brake, and then I'm just going to use a regular race quip shifter boot. And I've relocated my center, on the center console I came up with a little 3D printed piece to hold the window controls. Now as far as the hydraulics, the clutch hydraulics, I also stole that from the V8 Roadster's system. I say stole, I bought it from them, but I did have to ask them for an extended length clutch line. So the quick connect off of the MT82 concentric slave is actually the same as used on the T56s, so I was able to use that as well. And then finally, the clutch I'm using is a McLeod RST. It is a twin disc, and that is what's used in the Mustangs. So all of that stuff I've already test fit up. All that stuff should have no problem working. The only thing that we'll have to figure out is I do have a couple of finalization things I need to do with the center console, as well as there is a possibility I may need to shim the concentric throwout slave. So that's pretty much it. Next, let's go ahead and discuss the choice of the differential. So after I sorted out the transmission, I decided obviously we wouldn't have a power plant frame, so once again, taking from the V8 conversion guys, I went ahead and grabbed a V8 Roadster's AAM rear end conversion. It was between the Ford 8.8 and the AAM. The AAM just made more sense for price-wise and accessibility-wise, so I went ahead and got one of those. Really, it's one or the other, doesn't really matter as much. But the AAM I chose was out of a Camaro, of course, and it has a 345 axle ratio as well as an integrated LSD. So, combined with the gear ratios of the Mustang transmission, the EcoBoost Mustang transmission, and the diff, you'll see that the comparison of stock ratios, because the stock I was using I had a 6-speed and a 410 rear axle ratio, as all of them do here in America. The drive shaft I had to get custom made. It's a beautiful big aluminum piece, and all I did was I measured the distance between the two components, and I said, okay, I want to have that be my almost maximum distance, and I gave the minimum and maximum distance for the slide joint as well as the flange sizes, and the local drive shaft shop was able to make one for me. And the V8 Roadsters kit also came with the beefy axles from the drive shaft shop. Not the drive shaft shop locally, but the company called the Drive Shaft Shop. But that's all it was really needed for the rear end. So we welded up the pieces to mount it, so the diff is just by itself. Again, doesn't need a power plant frame, so that's all sorted. We're not worried about breaking anything on the rear end. So let's discuss the turbo system. The turbo system, I didn't want to go with anything that was too outlandish, so I went ahead and went with a Fab 9 turbo kit off of the shelf. It is an EFR kit, but ironically we're not using an EFR turbo. But I liked that it was a low mount as well as it was V-band, so I went with their system, and I switched over to using a Garrett G3660. So some of you might question, but the EFR is the best? Well, in my opinion, the G series is the best, because the G series actually came out later than the EFR series. And if you look at some of these maps, the map of the G3660 that I've chosen, it's superior in every way to both the 6758 and the 7163 series turbos. I will happily throw the maps up on the screen so you guys can see what I'm talking about. But as far as the fitment under the hood, the G3660 is physically a little bit smaller, so the turbo sits, I think it was a 1/4 inch or so higher up, because it doesn't hang as low from the manifold. Had a little bit of fitment issue on that, but I got it on there, and it is a really tight squeeze. Other than that, I modified a little bit of the piping, because the EFR is of course an integral wastegate end blow-off, so the integral blow-off, that doesn't carry over. The G series is integral wastegate but not integral blow-off, so I went to an external blow-off and I chose the Turbo Smart Race Port. So the funny thing is the street port is rated for like 600 horsepower, and since I'm bordering on that, I just went ahead and said, let's go safe, and we went up to the race port, because the race port is rated for something like 2,000, 2,500 horsepower. That's fine. As far as all the piping, it hasn't all been set in stone yet, but we're going to see about using most of the Fab 9 piping. Aside from that, we did already weld up the piece of the blow-off valve, so that way that can be accommodated into the build. But a little more piping modifications can be required, because we are using a zero limit intake. It's actually the last one that they made, and I also need to get that ported out, because the Porsche throttle body that we'll be using, while it is a bolt-on, the port on the zero limit is sized for the stock throttle body, and the Porsche throttle body is close to ½ an inch larger, so that will make a bit of a difference. As far as the choice of the turbo, the G3660 itself, I chose that one because I wanted to set my goals higher than the model below it, which is the 550. 550 is rated for 550 nominal horsepower, and I said, well, we're going to try and make more horsepower, so I just went into the 660. So even with a little bit of not going over the top with the 660, we could potentially make 500 to the wheel, maybe more. But that was the lower priority. I just wanted to go ahead and say, let's try and bump it up. So, I mean, I could have gone with the 700, whatever it is, or the 900, but I chose to go with the 660. It seemed more practical, if you will. So some of you may have seen my other video about fuel system calculations and stuff, so I based a lot of the stuff around that. And what happened is, I in wanting to run the 660 horsepower turbo, I said let's go ahead and base this around 660 horsepower on an ethanol system. So doing the calculation, I came up with that I needed a lot more fuel than I could get out of the stock fuel pump. The stock fuel pump, we can put in up to a 340 liter per hour unit, but the problem is that 340 liter per hour is a nominal. Nominal meaning like at 40 psi it'll run 340 liters per hour, but you have to remember that when you're running boost, then if you have a fuel pressure regulator that is going to be boost referenced, it's going to have to raise the pressure and you'll lose flow. So that being said, we are running a return system off of a surge tank. It's this is exactly why I designed my kit for this car. So the kits I offer on my website are based off of all the calculations and stuff that I wanted to do for this car. That's why I offer 3 sets. I offer just a regular return kit, I offer a small surge kit, and I offer a bigger surge kit. This is the bigger surge kit. And more than just being the big surge kit, the big surge kit is a 3.5 liter tank from DW, and it comes with one 350 IL tank. So IL just means it's their inline pump. But on top of that, I'm going to be running 2 of them. So it's going to be 2 350 liter per hour nominal pumps, which should run me enough fuel to make, let's say, close to 1,000 horsepower on ethanol, if I remember my calculation. But either way, it'll be ample for what I'm doing. The 2 pumps are going to be running, like I said, in the surge tank. So the stock tank with the 340 liter per hour in tank is going to be running fuel at no pressure or low pressure as a lift pump into the surge tank. The surge tank is going to have the 2 pumps running tandem into a wide joint, 8AN, all the way to the front of the car, and that feeds directly to the fuel rail. We have the fuel lab, fuel pressure regulator, and the reason I chose the fuel lab is because it was able to flow all of that fuel, and I could just run both pumps without having to do a kick up activation of the second pump, like an in-boost type thing. We wouldn't overflow the regulator. That's the biggest deal. So then that returns on a 6AN back into the surge tank. And we're also going to be running ID 1700 injectors because that's the biggest injectors I could get. So hopefully we don't run out of injector. So last thing before we actually get into looking at parts and the build, I'll go over the spec of the motor itself. So the motor I spec'd around what was available, and I tried to make best judgment choices there. I didn't want to go with a 2.4 liter motor. I wanted to go with a 2.5 liter. We're not going for a high red line or anything like that. We're putting a large turbo on, and well, it'll do its thing. So we went with a 2.5 liter motor, and I chose to go with SuperTech 1mm oversized Inconel exhaust valves. I went with SuperTech nitrided intake valves, stock size, the Kelford 211-T2 turbo cams, and their springs that go with them. Those are, so they have 2 levels. They have T1 and T2 cams, and the T2 cam is rated for an obnoxious amount of horsepower. For the 2 liter, it was rated for something like 500 horsepower on a 2 liter, so I went ahead and I'm putting them on this thing. And then with the oversized exhaust valve, that should help with a lot of the exhaust side flow. We went with SuperTech valve guides and seals as well, so this should be the manganese bronze valve guides and then the Viton seals. So all that's brand new. And I had it done at a very, very high-end shop, H Squared Racing. So they're very white glove, very precision, and as you'll see on the motor, all the work is really top-notch. The decked surfaces are superb. We get a lot of work from various machine shops, and you'll see a lot of the machine work. You can see the evidence of it, but on this one, it's definitely a cut above. So as far as the bottom end, we went with SuperTech 9.5 pistons, so they're 9.5 to 1 pistons. I don't remember the bore, but I believe we stuck with a bore, or the stock bore, or we went half a millimeter over. Nothing extreme. It's not like we're trying to bump up our displacement here. We used NPR rings. They are Molnar rods. We have ARP main studs, and then we went with Esslinger Engineering custom-aged 625 plus head studs. I'm using a Cometic MLX gasket instead of a regular MLS gasket. The MLX gasket is intended to have an even better seal, and then we also did the copper spray on top of it. So the process for the copper spray is whenever you start the motor up the first time, you're supposed to start up the motor with no coolant in it to try and bake that copper spray, so you'll have a really, really good seal. And I forget which main and rod bearings we went with, but I believe we went with King. I believe that's who we went with, but we went with a race tri-metal type bearing. This is the car, of course. The bumper is sitting up there as it has been for a while. Let's go on over. So we have a bunch of new OEM hoses from Mazda, new OEM crank sensor, a couple of the parts that'll be reused, the Porsche throttle body, the Fab 9 turbo manifold with the Garrett G3660 in the downpipe, some of these awesome copper lock nuts that are going to go for the manifold over here, the race port that this goes on the pipe that comes up out of the intercooler into the engine bay. So that's that guy. New starter. This is what the DW350 IL looks like. When we look in the trunk of the car, you'll see it hides inside of the box of the surge tank. Then we have our Fuel Lab inline fuel filter, Fuel Lab fuel pressure regulator, the radium rail. We got zero limit intake manifold. Then we have Esslinger Engineering, custom age 625 head studs, the radium baffle plate. Obviously it's been used, it was on my last motor. Injector Dynamics 1700s, the ITV24 spark plugs. This is the EcoBoost water pump with the different impellers. So the impeller has a much nicer shape to it, and that's this part number if you guys want to get one of those. Here's the head with the Kelford cams in it. The machine shop was kind enough to write down all the clearances they had on each of the lobes, but I'm going to go back and check again. The beautiful valve work. Over here we have the block. Beautiful pistons, and the finish of this thing is incredible. The machine shop really does some nice work. And we have race bearings, and let's see, over here I got my two seats, which look terrible because they've been sitting there a bit. The Mustang MT82 transmission with the MGW shifter. That is the shortest one possible to fit. The concentric throw-out slave cylinder, and a bunch of other parts that are sitting over here. Then we'll walk over. I have a couple of other parts sitting on the shelf, such as I have a distribution block for vacuum. I have a giant catch can we're going to attempt to make fit in the engine bay. Giant oil cooler from Mishimoto. I have two options for air filters. They're the same air filter, but one is a 2.5 inch and the other is a 3 inch at the base. We'll see what we can work with. I'd rather the 3 inch, of course. Two gauges. This is the boost controller end gauge. Carbon fiber sight for a steering wheel. And this is the McLeod RST clutch that is intended for use with an MT82. And that is the custom drive shaft. So now we're going to start taking care of doing some assembly. Oh, I almost forgot. The Goodwin Racing 42mm CSF triple pass radiator. Okay, our first step we're going to go through is install these Esslinger custom age head studs. We got one out of the package here. They came all nicely sleeved. We just thread them on in. So we got most of them in. Just need to have this last one in. After this, we're going to spray down the head gasket with the copper spray. So I wanted to show off this head gasket specifically. This is an MLX instead of your typical MLS. And it is also a 51 thou instead of your typical 30 thou like OEM. Also, if you look at this one is appears to be like a laminate. It has 5 layers or so in it. So we're going to spray down the surfaces, stick it on there, get the head on, and then follow the instructions as given here. We've put the head on, we've removed the cams so we could fit down those the nuts for the head studs. So the procedure says we're going to go 35 foot-pounds, then 0, then 35, then 0, then 35, then 0, then 30, 50, and 80. You'll notice these things are sizable. They are large nuts. So we're going to go through with my fancy snap-on torque wrench and torque this stuff down. We have our red line assembly lube here. We're going to cover these cams and these lobes up. We're going to spin the cams over, check our lash. We've taken care of the lash. We got all these down to all 8s on the intake and all 10s on the exhaust. You see our beautiful feeler gauges all covered in the red line assembly lube. So next step, we're going to take care of some of the timing components on the front. We do not have our crank pulley yet. It is ETA like another week or two. So we'll probably just fit on a bunch of the external stuff. New starter, a couple of new hoses, new thermostat, cams, the fuel rail along with the injectors. I got a couple of new seals in here. We were doing the Mad Fabworks oil perch, so this will be oil out to the cooler and oil in from the cooler, running a stock filter in stock location. This motor mount is missing a bolt because this is actually going to be taken back off before it drops in. I'm waiting on the gasket to come in for putting on the radium baffle. This is the radium baffle. We're probably going to run both of these ports just to make sure we got plenty of breathing. And then over here we have the turbo. So I will need to put the clip on here, but I wanted to demonstrate how close this is. So it'll be super close to the transmission, super close to the block. If absolutely necessary, this can be knocked off. We don't use this. And the fitment of everything here is exactly where it needs to be. So we are very, very close on all of these components here. There'll be just enough room for this stud right here with this nut. I actually took care of that in the pre-fitment checks when I was doing all of this stuff before the motor was sent off. So I actually had to grind down the stud on the motor mount to make that fit. As far as the front cover goes, I'm going to go ahead and get that guy painted. I figured, you know, I'm already here, I'm doing nice stuff for the car, I'll go ahead and take care of getting that painted along with getting this painted after I get that guy bored out. And then we're also going to have to, along with all the piping, we're probably going to just get all the piping redone after we're finished fabricating whatever is necessary. All right, I'm putting together the Goodwin radiator assembly. So we've got this big 42mm radiator unit. This thing's awesome. Got a new condenser I'm putting with it. And then I have my fan assembly over here, and I want to point out that this fan assembly, we never actually get these things sealing 100% against these. So what I've done is I put this low profile or D-shaped kind of weather stripping stuff, so that way it seals all the way around the edges. So that way when this goes on, it will be able to pull really hard against this and really get a lot of airflow across it. It's a pretty important detail. But I try to do this on all the cars, not just the NC Miatas. We do it on the NAs and NBs as well. So that way when this is installed, we get maximum airflow. So, okay, I took the fuel system out of the trunk just so I could give you guys a look at it. Also, I have to install this fuel pump, of course. So this is what the fuel pump looks like. This is the one that's in there. All it is you got these little lids that are on here, and then the little, I guess, the hold down. So we got a little gasket that goes around it. And this just drops right in here. And then make sure that gasket seats nicely. Set this piece over it. Put in all 6 bolts, put a fitting on there, and like I said, we'll wire those together. But that's the surge tank assembly. Putting together some of these fittings, trying to get all this worked out before it goes into the car. So I've changed out all of these for the PTFE style fittings. So we're going to be putting on PTFE lines. I had initially put in just regular stainless steel braided line, but I'm going to replace that all out. So I've used the Orb 2 PTFE 90s here. And then we have, these are actually, so these are going to be actually serviceable here. The only reason that I haven't done it for these 8ANs is because these are going to be feeding into the Y joint. So if you wanted to remove the tank, all you have to do is disconnect this. So I got to figure out where I want to put this. I'm not sure if I'll do this or, you know, lay it on the ground type thing. Then this will feed into check valve, into the filter. This is a non-check valved filter. In retrospect, I probably should have bought the model that has a check valve built in, but it's not a big deal. I already had a check valve on deck. Then we go up to the fuel rail, which is over on the motor, and then I have the actual regulator here. So I got all my fittings and I assembled this. Point to make here: don't use just regular Teflon tape. You can use it on this one because this one will only see air, because this is the reference port, but this one here will actually see fuel. So I use this stuff called Gasoila E-Seal. It's another type of sealant that is fuel friendly. This project has been going on for so long, and parts have just been stolen here and there for other customer projects, that I couldn't find these little guys. These are, if you recognize, they hold the radiator upper support. So part number just for reference. But I got 2 brand new ones from Mazda. Now time to install the radiator. All right, the new fuel filter just came in. I decided I didn't want to run this plus a check valve. I'm an idiot. I should have just ordered this one from the beginning. This one has an integrated check valve, so that makes life easier. So the part number on the other one was 01802, and the part one on this one is 04802. So same filter, just obviously it has a check valve at the end, so that'll help. Now let's step over here. Started making all these AN lines over again, this time again out of PTFE lines. Made up a bunch of the wiring for all of this nonsense. And then just got to finish making more of that stuff. I'm also waiting on parts to come in for finishing one of the last lines for the 8AN lines as well as the 6AN line. And then I'll be able to install all that stuff. Slow progress here. Fitted up all these fuel lines. Let's see. Took care of some of the wiring on all the fuel assembly stuff. Got both of the pumps in here. I shortened these lines up. Made them a little bit too long. Changed over to just the fuel filter that has the integrated check valve, so that'll simplify our lines in the trunk. Let's pop back over here. So on the drain line, I ran out of space with using the AN line fitting, but I found this actually used to be a lot longer. I think this is off of one of the Fab 9 GT kits, but this goes here, and it was running too close to the motor mount, so I cut it shorter, and I picked up some 5/8 aluminum tubing. We're going to weld that into place, so that'll give me more distance from the turbo to wherever this rubber line starts, and I'll run a short rubber line to the block. Now where on the block, not sure. Waiting on the fitting to come in, and then I'll drill and tap that. Here we're making my AN lines. This is coolant lines to and from. Put some fire sleeve on here from DEI. Love this stuff. Had to relocate that port down to here because of access to that bolt, as I may have mentioned. And then this just clears barely around all there. I do need to put a clip on here. I'm gonna have to put I guess a washer and a bolt on this because that's not gonna fit. And then same down here, that's not gonna, I really can't do anything there. These bolts are evenly spaced for 5 of them, and then one of them is not evenly spaced, so it's kind of weird. You can't just change orientation. Either way, some progress happened today. I got this back from the machine shop. They did a wonderful job boring this out, so we have a nice match to our throttle body. And then this fitting came in. I made sure to get aluminum, that way when these two expand we don't have too much of dissimilar metals. But I went ahead and drilled this out 5/8, and then I put in a 3/8 NPT to 5/8 hole. So what I'll be doing is getting this welded to match the position, and then we'll just have a short segment of hose there. Okay, so back in November I ordered a couple of these fluid dampers because that's when they were first released, and they finally came in here in like mid-late March. So I picked up this tool from Company 23. That's an installation tool, but it's an important detail to mention that they come with a 5/16 by like 18 thread for their bolts, because this tool is actually intended to be used on a Subaru. It's not intended to be used on a Miata or Duratec or whatever. So what I had to do is I picked up some bolts, and the little spacer thingies that they give you, I had to cut it down because they didn't fit. The holes are really, really close to the corners. So in order to get all that to fit together, as you saw, I just disassembled. In order for all that to fit together, you have to do different bolts, and you have to do the cutting down the spacers. So we're actually ready for install on this crank pulley. We'll be using the stock crank bolt, we'll be using the stock crank washer stuff, and also there is a hole on here, as you may have seen, for the alignment of the crank pulley. So this crank pulley actually needs to be installed upside down, as far as the logo goes, because that's the hole that we use for aligning up that dowel on the front cover. Aside from that, I'm really excited. We actually get to make some progress on the motor. So let's do it. All right, let's see if we can't handle this installation. So I have my torque wrench, I have my Company 23 tool, I have a new crank bolt, new crank washer, the crank pulley of course, and a Q-tip. So just time to cover this motor. It's been covered up for, a couple months now. That's very TDC. So as you'll notice, we really don't have a spot to mark on the crank pulley because we can't get to the crank pulley. Because I should have marked it before I put the tool on. However, the tool shouldn't be moving either. So we're going to mark here. We're just going to mark on the tool. Okay. I'm not trying to hurt myself today. Try not to most days, but you know, sometimes stuff happens. That's torqued. Okay, now that we have the crank pulley done, I went ahead and stuck the turbo system back on here. Since the last video I had made, the last video segment I made, a friend of mine had an extra one of these oil feed lines. He has the same, he has the EFR turbo system, and he was trying out a different setup. And so this line, as you see, it's a very nice line. I think this is from Race Flux. That's who it's from. So it's already heat shielded and stuff. I'll probably even put more heat shielding on it. It has a 90 on one end and a straight on the other end. I think best config, we're probably going to end up with a 90 over here. I need to check and see what kind of engine bay clearance I get. But this will set me up really nicely to go around and to the Mad Fabworks perch, as you see. Nicely threaded into there. Let's see. Oh, I just got another brand new hose from Mazda. Apparently the little hose segment that goes right here, you can't just buy that hose segment, so it's a little hose segment and it's a whole tube. So that guy will go up here. We now have a turbo drain. Let's take a look. So what we ended up doing is cutting off the section that was attached to the little flange and then just welding a thicker walled piece than I had before. This is not the original piece I had. This is it's probably like triple the wall thickness. But we've now welded that on. It fits really nicely. I'm gonna put a small rubber coupling here. And now that we have this done, I'm gonna go ahead and take care of doing the exhaust gasket and getting all those nuts tightened on. We're gonna drop the motor in finally. Okay, so I mentioned before, I believe, that the spacing between the bolt holes on the compressor housing are uneven. So the distance between these two is the longest, the distance between these two is slightly less, and then the distance between the other ones are all standard Garrett bracket spacing. So I got the bracket there, but I couldn't make a bracket work here since the wastegate is of course on the other two over there. So that leaves me with this and that one empty. So I needed to modify, or pretty much just cut in half the bracket I have. So this one just goes here, that'll be fine. I misplaced a bolt, so I don't have one at the instant, but I cut the other one of the bracket, modified it so that it'll just butt right up against there, and that'll just hold regular spacing like that. So that'll be nice and secure. Checking out the engine bay, I didn't realize I never cleaned up all the oil spills from the last couple of motors in here, so I cleaned up all of this. This is now all clean. Cleaned up the wall over here and added a bunch of the DEI heat shielding, because that's where the turbo is going to be. But before this transmission goes in, I'm going to rip out the old DEI and put in some new, since now they've come out with templates that nicely fit. Big stuff, we're ready to install. Let's just give it a last walk around so you can see everything that's going on here. Oh, I did take the downpipe off. It's just going to make life a little bit easier for the install. And in it goes. And without further ado, we have the motor installed. I'm going to cut this video off at this point. We're going to go ahead and make part number 2 whenever I move into the next stages. Thanks for watching.